Hi everyone, today we're going to be continuing our lesson with annuities, and this time we're going to be looking at the regular payment. So this is just the other formula that we looked at yesterday rearranged. So R is equal to PV times I all over 1 subtract 1 plus I to the exponent negative n. All right, let's take a look at a couple quick examples here. Amy is buying a $220,000 house. She's getting a 25-year mortgage at 6.3% compounded monthly. What will her monthly mortgage payment be? How much will she actually pay for her house? Okay, so we need to decode the question again. So I'm going to start by writing down my PV, R, I, and N. And so this time we know what the amount or the present value is. It's $220,000 for this house. We need to figure out the regular payment. Interest rate is 0.063. Remember, divide that by 100. So in other words, we're moving the decimal 2 places to the left. And compounded monthly, so divide that by 12. The number of payments, so if we have a 25-year mortgage, that's 25 times 12 payments a year for a total of 300 payments. All right, we're going to go ahead and we're going to plug it into our formula. So R equals 220,000 times the interest rate, 0.063 divided by 12. All over 1 minus 1 plus 0.063 divided by 12. And then to the exponent negative 300. All right, so be careful here. Some of you may have to enter the numerator separately and then the denominator, keeping all of your decimals, and then divide those two numbers. Some of you can open up a series of brackets and get this on your calculator directly. And some of you are lucky and could just enter it as it appears and it will give you the correct answer. So on my calculator, I have to type in 220,000 times, open up a bracket, 0.063 divide 12, close my bracket, equals divide, open up 3 brackets, bracket, 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 1 minus, open up 2 brackets, bracket, bracket, 1 plus, open up a bracket, 0.063 divide 12, close 2 brackets, exponent negative 300, close a bracket, equals, and you will get $1,458.08. Okay, so that's the mortgage payment. Okay, so how much will she actually pay for the house? So this is the sad reality. So $1,458.08 times those 300 payments, and you get $437,424. How sad for poor Amy. So the total interest that this Amy had to pay is $437,424 minus the original price of the house, $220,000. I'm going to try to squeeze this in here. $217,424. So almost double the original price of the house. So she could have bought 2 houses. All right, I don't have enough room for a therefore statement, but it is a word problem. So we should have a conclusion. Her monthly mortgage payment will be $1,458.08. And she actually pays $437,424 for the house. All right, our last example is Alex. Alex got an $8,000 loan to buy a car. The interest rate is 7.2% compounded monthly. What will her payment be if she is set up to pay it off in 3 years? How much will she actually pay for the car? So similar to the previous question, just on a smaller scale. So let's decode the question. We are going to write down $8,000 for the present value of the car. We don't know how much the payments are yet. Converting our percent to a decimal, we get 0.072 divided by compounding monthly is 12. 3 years times 12 is 36 payments. Okay, go ahead and plug that in. So 8,000 times 0.072 over 12, all divided by, big bracket, 1 minus 1 plus 0.072 divided by 12, the exponent negative 36, and go ahead and plug that in. So again, you may have to enter the numerator separately, the denominator separately, and then divide those two. And you should get $247.75. How much will she actually pay? So we multiply that regular payment by the 36 payments. 247.75 times 36. Should put it there for a statement here. And that equals 819, or sorry, let me fix that. $819,000 is what she actually pays. And if you wanted to take it one step further, although the question doesn't ask for it, you could figure out the interest paid. So the original price was $8,000. Take away the $8,919. So the interest was $919. Still, that's significant, right? $919. That's quite a bit of money. All right, that's it for this lesson.